And finally, ladies and gentlemen, let's perform an actual proof. For our first proof with coordinate geometry, we're going to prove the parallelogram diagonals theorem. Before we get into this proof, I want to take you down memory lane. How did we do this proof previous to coordinate geometry? It looked something like this. Remember these things, statements and reasons? We started off with given. KLMN is a parallelogram.
Ooh. Which then tells us that segment LM is congruent to segment NK. That's by the parallelogram opposite sides theorem. Now we can use the definition of the parallelogram to say that we have a pair of parallel sides there. Segment LM is parallel to segment NK. And because lines are parallel, we have some congruent angles. Angle LMK is congruent to angle MKM, and angle MLN is congruent to angle KNL by the alternate interior angles theorem. Remember that from way back when? Oh look, and now we have some congruent triangles by angle side angle. Oh my gosh, does this stuff ring a bell? And now because we have congruent triangles, corresponding parts of congruent triangles are congruent, or the definition of congruent polygons tells us that segment LH is congruent to segment NH, segment MH is congruent to segment KH, and finally, because the segments are congruent, we know that they bisect each other by the definition of segment bisector.
Phew! How's that for wild and crazy? Remember that? Great big long proof. Let's see what it looks like using coordinate geometry. First, let's find the midpoint of segment KM. That's easy, we use the midpoint formula. We take our x coordinates, add them together, divide by 2. Our y coordinates, add them together, divide by 2. Zeros don't mean much, and then we divide everything by 2. So the midpoint of segment KM is a plus b, y. So that's the midpoint. That means that the bisector of segment KM has to go through that point. Next, let's find the midpoint of segment LN. Again, midpoint formula. We add our x coordinates together and our y coordinates together, divide both those sums by 2, and reduce. Oh, look! The midpoint of LN is exactly the same as the midpoint of segment KM. Do you remember this interesting postulate learned back in the first lesson of the school year that said if two lines intersect, they intersect at exactly the same point? Well, we have two lines that intersect, and they each go through the same point. That means point H, the point where those two lines intersect, has to have that coordinate. Oh, wait a minute. H is the midpoint of both segments. Therefore, by definition, they bisect each other. Wow. 4 steps. Compare that to the previous stuff with 7 steps. Can you see how powerful coordinate geometry can be?